Hello, welcome back. So I'm going to look at the halogens now. As I said before, the halogens are in group 7 in the periodic table. So each halogen has 7 electrons in its outermost shell. So in order to get a full shell, the halogens need to attract one more electron in there in order to get to the magic 8. Okay, so I want you to keep that in mind. I'm not sure if I mentioned that with the alkali metals. Alkali metals were trying to lose an electron, remember, in order to get a full shell, get the stability. So it's a similar, the words involved in describing this trend or explaining this trend, sorry, are very, very, very similar. Still stick with the ideas of shielding, shells in the way of the positive nucleus, the nuclear charge, and the outermost shell. Still increases as you go down the group from the top to the bottom. Also, the atomic radius, the distance from the middle to the outermost shell, also increases as you go down, which again makes it more difficult for the nuclear charge to have an effect in terms of holding on to the outer electrons. Okay? So I want you to keep this in mind. What the halogens are trying to do now, though, is instead of trying to lose an electron, they're trying to attract one in. So if you think about this, the positive charge in the middle of the nucleus, it's much easier now for fluorine to be able to attract an electron in there than it is for instance, bromine in this case. Okay, so there's fluorine, chlorine, bromine, iodine, astatine and tennessine, which was discovered not too long ago, I don't think. As you go down the group, the melting points and the boiling points also increase. Think about it, you've got fluorine and chlorine, which are gases at room temperature, they have very low melting points and low boiling points. As you go down, that increases. Again, stronger molecular, intermolecular forces between these molecules, which are diatomic. Diatomic just means they hang around in pairs, so we tend to write them like this. Oxygen's another diatomic molecule. Very important one for us, isn't it? Okay, so again, larger atomic radius as you go down the group. There's more shielding, which makes it harder for the atom to attract an electron in order to gain the full shell. Okay, so I just want you to keep that in mind with the halogens. Halogens also, we also need to look at displacement reactions, which I'll do again in a standalone lesson later on. In terms of what displacement is, it doesn't just happen with the halogens, it happens all over the place in chemistry, it's very important. We'll talk about oxidation and reduction reactions, redox reactions, so much fun in chemistry. So you've got all of this to look forward to. So far we looked at the alkali metals, the halogens, the structure of the atom, and how they're labelled, and what the numbers, the atomic number and the mass number mean on the periodic table. So I'm going to quickly move on next just to electron shells, the rules, and how to fill them in. Most people tend to get this pretty quickly. It's just about remembering 2, 8, 8, 2. And that's it. But we'll need to know that when we move on to ionic bonding, covalent bonding, in terms of representing them with dot and cross diagrams. Okay, I'll be back shortly.